Thank you for reminding me, Manmohan. That's good. So the gym structure question 2. So it's on various drawings. The first one that shows up is on 9548. So using your scale on this drawing, the scale is 1 to 500. Now, it's possible that some of you didn't pick up on the fact that when you print drawings on 11 by 17, they're not full size. A full size drawing is approximately 2 feet wide by 3 feet long, so 600 millimeters by 900 millimeters. So when you print those full size drawings on 11 by 17 paper, which is what I have, and I assume maybe what you have done also, it shrinks everything down. So the scale becomes out of whack. So you would need to find a dimension somewhere on your drawing and come up with a factor that you would need to multiply scale dimensions by in order to get the actual length of pieces that you're measuring. So when I did that, yeah, so an easy way to do that is looking at the control line. So if I go up on the drawings here, if I zoom in on the parking lot, we talked about this control line last week, so right through here. So from 0 plus 100 to 0 plus 120 is, of course, 20 meters. So when you put your 1 to 500 scale on there, it shows up being approximately between 8.5 and 9 meters. So there's an adjustment factor that you need to do in order to get that length to be the actual 20 meter length. So it's a factor that you need to bump up. So scrolling down to my gym, when you scaled this gym, you would get approximately 23 meters wide by approximately 43 meters long. So somewhere close to those two dimensions is what I would be looking for. Question 3, what's the depth of manhole D1? So shows up on drawing 9553. So this one, so this is of course the storm sewer drawing. So it was manhole D1. So this is manhole D2. So D1 must be this one, right? There's our manhole D1. So what is the depth of this manhole? So we've got inverts, right? We've got an invert in and an invert out. So you would take the lowest one. The lowest one is 60.92. So that's we're taking that as the invert of our manhole. Now we need to know what the top of the manhole is. So if I scroll down to the profile, so here's manhole D1. There's the symbol for it. So right here on this line here is the rim elevation. So that would be the top of the manhole. So for depth of manhole, the question, you would go rim elevation minus invert elevation. So 63.3 meters minus 60.92 to give you a depth of 2.38 meters. So question 4, name the specified materials that can be used to backfill over a utility pipe. So if I zoom out here again, so backfill, there are some notes on detail drawing 1, so DET-1, that's this one here. So if I zoom in a little, come over, so here's our standard detail drawing for utility trench. It's drawing G4. This is, it shows up in the MMCD document, the Master Municipal Construction document. There's MMCD right there. So we're told specified materials can be used for backfill over a utility pipe. Zoom in a little closer. So you're just looking for material types on this typical trench here. So one possible solution is match existing, right? Depending on if you're in a boulevard and or an easement versus if the trench is in a road or a lane or a walkway, so in a traveled section where cars can be. That's the two different types of trenches that we're looking at here. So there could be native backfill. Native is typically only allowed in boulevards and easements where vehicular traffic will not be. So over on the vehicular side, so in roadways, we've got import granular. So that's imported gravel of some specified type. There's granular pipe bedding. That's a different kind of gravel that goes right around the pipe zone, so right around the pipe itself. There's also these this wider section here. So there's asphalt on the top, that's the solid black, and then these two thinner layers are the pavement structure, or the remainder of the pavement structure. So there's road base and road subbase, and that shows up just above standard drawing G5. There's base and subbase. Those are the two thinner layers below the asphalt that show up down here. So question 5, what is the excavation cut for the access road at chainage 0 plus 155? So what is the excavation cut? So it should say cut depth. The word depth is not in there. So it talks about the access road. So we need a drawing that deals with the access road. So if I go back in my drawing set, so here 9552, this was the access road. If I zoom in here, it's labeled gravel access. So that's this whole piece here. So if I scroll down on this same drawing, we get the profile. So starting at 0 plus 90, going up to almost 0 plus 200. So when I scroll back up to the plan view here, so 0 plus 90 should be this end down here. 0 plus 100, it looks like, is the first station of the access road. And then it swings around. There's 120, 140, 160, 180. And it looks like it ties into the existing access road right about here, 0 plus 185 maybe. So we're being asked to look at 0 plus 155. So it's likely right in here somewhere. So it doesn't give us any information on the plan view. We have to scroll down to the profile. So there's 0 plus 150. Here's 0 plus 160. So of course, halfway in between the two is 0 plus 155. So the question is, what is the excavation cut for the access road at this station? So when we look at the profile itself, the dashed line is the existing ground surface before any work starts. And the solid, the dark line, is the design access road finished grade. So top of road surface, whatever that surface happens to be. So looking at 0 plus 155 right here, we are looking at this piece right here. So there's our original ground at whatever elevation that is, and that's our finished grade. So how do we know what those two numbers are? We're given a elevations on the side here, but you don't have to scale this to come up with a elevations of the two. We're actually given, trying to draw a box there, it's not working. We're actually given the two required numbers to us. So the number on the left of the line says 58.1. That is the original ground elevation. So when you look over here, you say, well, that says 56 right there. Well, we're actually not going all the way over to here. We're only going to this line here. Notice there's more numbers here. So 58, there's the 58 line. So we're just above that. So that's 58.1. I'll zoom in a little closer. So we're looking at, yes, this line right here. So there's 58.1. Now the other number that we're given, this 57.25, is the finished grade of the access road at this station. So now I keep saying the word finished grade. So what does that mean? If we slide over here, so this is a typical cross section of what that access road looks like. Finished grade is the top surface, right where my pointer is. So it's, if you were driving a vehicle, it's where your wheels would be on the road. That's the finished grade. So we can see by this cross section that there's some thickness here of access road structure that's to be built. So when we look up here in the notes, it tells us what that structure is. So there's 75 millimeters of asphalt millings, 100 millimeters of road base, and 200 millimeters of road subbase. So if you add those three thicknesses up, that's 375 millimeters, or 0.375 meters. So we keep that number in mind, 0.375. We come back over to our profile to here. So if we simply subtracted these two numbers, original elevation of 58.1, if I grab my calculator. So 58.1, subtract this 57.25, which is the finished grade at this station. So 57.25. Now that's the cut distance from original ground to the top of the finished grade. But we need to dig more out in order to get the road structure in for the access road. Right? We just said that that thickness here is 375 millimeters. So we need to keep digging down lower. From this point, we need to go down a further 375 or 0.375 meters. So after subtracting 58.1 minus 57.25, I need to subtract a further 0.37, sorry, I need to add a further 3.375 to get the overall excavation depth from this dashed line point, which is the original ground surface, down to 375 millimeters below the finished grade. So that's our total cut depth at this station. That cut depth is 1.225 meters. Okay, so next, question 6. What's the specified minimum cover of the sanitary line? So on drawing 49, this one, which should be our servicing plan, right? This is our utility plan. So this will give us all the information on our utilities. What's the specified minimum cover of the sanitary line? You would have to read through the notes. So there's waterworks notes, so that doesn't relate to sanitary. So we come down here to the storm and sanitary notes. And so note number 13, minimum cover for sanitary is 1.5 meters under traveled areas and 1 meter under non-traveled areas. So that's where you would find that. Question 7, what is the diameter of the water meter bypass? So the water meter bypass, so that's a utility. So we could stay on this drawing. So the water is the blue. So if I zoom in close here, this box is the water meter. Now this note doesn't give us any information on this box. However, it does tell us to refer to detail drawing number 2 for additional details. So this happens a lot with not only utilities, but all sorts of items on your drawings where there isn't enough room to draw something in detail at a certain scale. You will be told to refer to a different drawing for a blown up version to give you all the details that are there. So for this water meter, we need to go to detail sheet number 2. So there's detail 1. Here's detail 2. I actually pointed this out to everyone last week. So here's the water meter chamber. Water meter chamber details. So I'll zoom in a little closer. So the question was, what's the diameter of the water meter bypass? So this is the main line running through the water meter. This pipe section here is the bypass. We're told the bypass is 150 millimeters. So that's your answer, 150. We'll come back to this detail a little bit later for actually when we do a practice assignment in today's class. So next question, question 8. What is the vertical exaggeration of the profile of the access road on drawing 52? So drawing 9552. This one. So again, it's our access road drawing that we were just looking at. What's the vertical exaggeration of the profile? So we have to scroll down to the profile. So I mentioned this last week also. So if we look at one square here, so if we look at this dimension first, the horizontal, we can see by the stations that the length of one box is 5 meters. So from 0 plus 90 to 0 plus 100 is of course 10 meters. So we're half that distance. So this length is 5 meters. So what's the vertical height of one box? So we have to look at the elevations that were given. So from one line, so from here is 62, up to the next number that we're given is 63. So half of that distance, so one of these boxes is half a meter. So this is 0.5 and this is 5. So you would say that the vertical exaggeration is 10 times what the horizontal scale is. So if you think of the calculation, how you come up with that, you would take 5 meters horizontal and divide by 0.5 vertical, and that gives you 10 times. So question 9, how many modules are needed in the infiltration tank? So infiltration tank shows up on drawing 9550. If I zoom in here, scroll down a little. That was our gym structure. This right here, zoom in a little closer. This little grid area here is the infiltration tank. So it gives you some dimensions. So it looks like it's 9.1 meters long, 5.9 meters wide, and then 0.9 meters tall. So now there is we're told here, see detail at right. So again, because not all of the detail can be shown on this part of the drawing at this scale, we're told to look elsewhere for a blown up version. This one. So we're told, here's the module dimensions. So each individual module, think of them almost like milk crates. They fit together like plastic milk crates. So each module is 457 wide, 917 long, and 457 deep. So we're told back over here on the plan that our infiltration tank is 900 thick or 900 deep. So we're told here 910. So if a module is 457 deep, that means if I go 910 divided by 457, so it's two modules thick or deep, this infiltration tank. So we know there's 2 layers of them. So now the whole tank is 5.9 meters wide. So 5.9 meters on my calculator, and we're told each module is 457 millimeters wide. So if I divide by 0.457, we get 13 modules wide. So we're 13 wide, 2 deep, or thick, if you want to think of it that way. So our last dimension here, the length, we're told the length of the tank is 9.1 meters. So on my calculator, 9.1 meters. Each module is 917 millimeters long. So if I divide 9.1 divided by 0.917, so that gives you 10 modules long. So all you would simply do is multiply those 3 together. So 10 modules long times 13 modules wide times 2 modules thick gives you 260 modules in the tank. Typically, those are sold by the module, so you need to know how many you need to buy. Okay, question over the page. Question 10 is, what is the specified compaction of the parking lot fill? So the parking lot fill on sheet 9551. So this is our roadworks details. Zoom in a little here. We see, if I zoom in even further, there's a note here that tells us what the parking lot structure is made of. So there's 65 millimeters of asphalt. There's 100 millimeters of crushed base course. Tells you what that compaction is. It's 95%. There's 200 millimeters of crushed granular subbase. It is also compacted at 95%. Both modified Proctor. So, just checking the roadworks notes. So that's the road structure. That's the road base, the road subbase. What about the fill that is underneath the road subbase. Well, looking in the roadworks notes, note number 2 here, so it says to remove all organics, so that's all the stripping, like the topsoil type stuff. So subgrade is compacted to 95% modified Proctor again. Yeah, so we're seeing 95% modified all the way through here. Here again is the base and subbase to be compacted 95% modified. So that's your answer, is 95% modified Proctor. So question 11, what's the elevation of the parking lot at the western catch basin? So we're sticking with this drawing because it gives us the details of the parking lot. So we have some grades here. So if I zoom in, well, which way is west? We need to figure that out first. So there's our north arrow. North is the top of the page. So of course this end will be the west end. So if I zoom in, west end. So we can see here that there's a catch basin right in the corner at the west end. The catch basin, the rim, so the top of the catch basin, is set at an elevation of 62.6 meters. So that would be the elevation of your parking lot down at this end. We also see this circular elevation note here. So there's usually a little X. It shows up better on this one. So wherever the little X, that's where that elevation is exactly for. So the little X is probably right here, right in this corner. It's kind of hard to see. So question 12, what's the specified frequency of sweeping the access road? So that shows up on sheet 9555. And it will be in the notes. So I didn't write down which note number it was. It's supposed to be daily or as required. Here we go. So it's note number 8. Make a note of that. So note number 8, if I zoom in a little closer, no mud shall be tracked onto streets. Employ a street sweeper as required. So sweep as required. Now there may be more comments on that in here. Okay, quickly scanning through it, it looks like it's as required. So if you, yeah, drawing 9555. So question 13 is, what company is the specified supplier for the type 2 oil interceptor? So that shows up in the details. Detail drawing 4, we're at the end. So when you zoom in here, you see we have type 2 oil interceptor. That's the detail for it. So it's the Langley Concrete Group is the specified supplier. So that's the answer to that one. So question 14, what government acts may be violated if prohibited substances reach drainage works and cause a mess or foul up the drainage? So dirty water running off site is what they're getting at there for that question. So again, we're on drawing 9555. Again, we're looking at the notes. And I show the Fisheries Act and the Waste Management Act. So here we are, prohibited substances. So it's in note 16, it's the third paragraph. Oh, that's just the definition of prohibited substance. Milligrams. So yes, here we go. The Waste Management Act, there it is there. And the Fisheries Act. So they're both mentioned there in the third paragraph of note 16. Okay, and then the last question, number 15, was what is the cross-fall slope on the access road? So another access road question, so we need to flip to that drawing. So here's our access road question, or drawing, sorry. There it is there. So you can see some notes here on the plan view where it gives a grade, so 12%, 12%. Those are not crossfalls though. Crossfall is, if I zoom out a little bit further, scroll over and down to the cross section, the crossfall goes across the road. So perpendicular to the control line. So the crossfall slope is shown here as 2%. So that's the number I'm looking for there. So question number 14 is environmental government. 14 government acts. So I was looking for, it specifically says Fisheries Act and Waste Management Act. So I was looking for either or both of those. Okay, so that was assignment 1. So any other questions on assignment 1? For the gym dimension, yes. Question 11. How is it possible to measure with an accurate scale? Okay, I'll go into that one in a little more detail. So, what drawing is this? 48. Okay, let me share my drawings again. Okay. So, looking for drawing 48. So this is the one that I used. Now you could use another drawing. I don't believe any of the drawings actually give you dimensions of the gym. I'm just going to quickly scan through. It does not look like it. Okay, so this issue comes up a lot. If you're estimating with drawings that are not printed to full size. So in other words, you're using say 11 by 17 size drawings. So here's our gym. Okay, so we're told that the scale on this drawing was 1 to 500. It says down here in the title block, right here, 1 to 500. Okay, so now we know that our 11 by 17 drawing is not printed at full size. So we know if we use our 1 to 500 scale on our 11 by 17 drawings, we're going to get incorrect distances. They won't be correct. So how do we come up with a scale factor in order to ensure that we get correct distances when we're using our 1 to 500 scale? So I'll go into a little bit more detail on how I did that. Whoops. So if I go up to the parking lot again, where the control line is, so ideally you're looking for something that is dimensioned on the drawing. So there's a given dimension somewhere that you can put your scale on to see if what you scale matches what the given dimension is on the drawing. Unfortunately for us, we don't have a given dimension on this drawing. What we do have though is, again, it's this control line. So from 0 plus 100 to 0 plus 120, or even better, let's go even further. Go from 100 to 140. Using longer distances will give you a more accurate measurement. So from 100 to 140 is, of course, 40 meters distance. So if I put my 1 to 500 scale onto my drawing, and I measure from 0 plus 100 to 0 plus 140, I get, it looks like about 18 meters. So let me just do that again. Trying to be as accurate as possible here. So yes, I scale it with my 1 to 500 as 18 meters. So my drawing says it should scale out to 40 meters, but I'm measuring 18 meters. So it's, what I'm measuring is smaller than what the number should be. So if I take my measured number of 18 in my calculator here, so 18, I just don't want to do this backwards. Yes, okay, so if I take my given dimension of 40 meters, so that's what the distance is between, or on my control line, from 0 plus 100 to 0 plus 140. So 40 meters long is what I'm trying to measure to. When I put my scale on it, I get 18 meters. So if I take my calculator, I go 40 meters divided by 18. That gives me an answer of 2.22222. So what that tells you is, whatever you measure with your 1 to 500 scale, you need to multiply it by 2.22222 in order to get the actual distance. Yeah, exactly. So to prove that to ourselves, so I'm going to take my scale, I'm going to measure from 0 plus 100, I'm going to go up to 0 plus 200. Okay, so that is 100 meters on my drawings. So with my 500 scale, it comes out to just over 44, maybe 44.5. So what do? I take my measured distance of 45.5 and I multiply it by my factor of 2.2222. And it gives me, the answer it gives me is 101. So it gives me a very close real dimension for the actual distance. So when I do that, when I put my 1 to 500 scale, if I scroll down here, onto my gym structure. So if I measure this, the width of the gym here with my 1 to 500, it looks, on my 1 to 500, it looks like it's exactly 10. So I'll go 10 times 2.22222, which is about 22 and a half meters, something like that. Similarly, for the length, with my 1 to 500, I get, it looks like 19. So again, I would go my measured distance of 19 times my scale factor. So 19 times 2.22 gives me about 42 meters, 42 and a half meters, something like that. Okay, so time is 7:23. Put my drawings away. Okay, so week 2. We're going to review. I stop my screen share. We're already here. I can't go into too much more details on assignment 1. We're not going to have enough time to finish off this week's information. So if you have further questions to assignment 1, please either ask at the end of class or maybe send me an email. Right. So we're going to do the PowerPoint presentation. So here we go. Okay. Can everyone see the PowerPoint slide? It says number 2, labor, materials, equipment, quantity takeoff. Yes, okay. So week 2. So estimating, what is estimating? Or what is an estimate? So it says there, to give or form a general idea about the value, size, or cost of something. So for us, it's a construction project. So it's based on things like design drawings, specifications that are provided. Using those design drawings and specifications, it ensures that all bidders are bidding on the same requirements. So same scope, if you want to think of it that way. So why do we estimate? So as it says there, our clients expect an approximate and or a firm price that we can deliver a defined scope of work for. So general contractors will bid on work, so maybe to municipalities or developers. So when they bid on that work, those general contractors also get subcontractors who price to them in a similar fashion. So the general contractor is providing a firm price to an owner. So what they're saying is, we can build this project based on these drawings and these specifications for this dollar amount. So how do we do that? How do you create those estimates? How do you come up with those dollar amounts? So we need to calculate things like the total effort and the resources required. So their costs plus our profit. So what is our effort and resources? What does that mean? So effort and resources are those bulleted items there. So labor costs, equipment costs, materials, subs, indirects. So what's an indirect? An indirect cost is something like supervision. So your superintendent is on the job site the entire duration. Maybe there's site office costs. Maybe you have security. maybe there's temporary power. So it's things, indirects are things that are not permanent. They're not going to stay on the site. They won't be incorporated into the project once it's complete. Indirects are typically removed from site after the job is built. So the supervisor goes, once that job is built, he or she goes on to the next project. So two important concepts here. First one is you need to calculate quantities. That's basically what this course is getting you to do, is calculate quantities. It also does one other thing. You're determining your labor and equipment hours, so the number of hours to do certain tasks. Once you can calculate those hours, you can put hourly rates to them and come up with overall labor and equipment costs, and then you'll have material costs on top of that. So that's basically what this course is all about, is coming up with those quantities, those hours, and putting dollars to them. So the first one, labor costs. So there's a note here, it says that minimum should meet the BC Employment Standards Act. So there's labor laws for how labor is paid. This next bullet there is, so terms of any collective agreements that may be in place, those must be met as well. So like for a union, there may be different or additional rules or requirements for the union that the employer would need to pay. We're not going to get into union agreements in this course, but just understand that they're there. So we're looking at, so labor costs, we're looking at hourly wages plus the additional costs that are on top of wages that employers have to pay. So labor costs include things like, so the base wage, there's overtime, right? If you work so many hours in a day or so many hours in a week, you would be paid overtime. So you get paid for statutory holidays, for vacation pay, so employment insurance, or EI premiums as it's referred to as. Canadian pension plan is another cost. So there's Worksafebc premiums. There are possibly RRSP or pension plan costs. Not every employer does RRSPs or pensions, so that can vary from employer to employer. Other burdens like things like union dues, your medical services plan, so there's a cost to that. Extended benefits like dental and eyeglass coverage. So all those things are costs to the employer that need to be accounted for in your estimates. So if we look at base wage, so these are just samples. So we've got a few different labor classifications here and their base hourly wage. So you can see them there on the PowerPoint. So when the foreman says, or forewoman says that they make $33 an hour, the employer, it costs the employer more than $33 an hour to have that person on the crew. So how do we determine those numbers? So the first one we'll look at here is overtime cost. So an employer must pay an employee who works more than 8 hours in a day 1.5 times the employee's regular wage for the time over 8 hours. And the second bullet there, so part B, is the employer must pay an employee double the employee's regular wage for any time over 12 hours worked in a day. So to summarize, anything up to and including 8 hours a day is paid at regular time, so straight time. From 9 hours to 12 hours, so 9, 10, 11, and 12 hours in one day, those hours are paid time and a half. And if you work more than 12 hours, so 13 or more hours in a day, you would be paid double time for those hours that are over and above the 12-hour cap. So there's another requirement for overtime, an additional part to calculate overtime. So the next bullet there, an employer must pay an employee who works over 40 hours a week. So that the next part of the sentence there is a union agreement that we're not really going to touch on. So who works over 40 hours in a week? So you could work 8 hours a day, right? But if you work 6 days a week, you're going to work more than 40 hours in that week. So anything over 40 hours is paid time and a half. So the last bullet there, this is the minimum. Collective agreements may differ. So again, collective agreements are union type agreements. So those agreements may modify this slightly. So that's overtime. So employer labor burdens. So things like statutory holidays. So for this bullet here, we're looking at 10 stat holidays in a year. So that was based on 2016, the year 2016. I think there's more than 10 now. So an employee who is given a day off on a statutory holiday, or is given a day off instead of the statutory holiday, so must be paid an amount equal to at least an average day's pay. So we had, I guess earlier this week, we had a stat holiday, Easter, right? Easter Monday. So that's a stat holiday. So you would get that day off, but you would be paid your full 8 hours because it's a stat holiday. So again, that's a cost to an employer. So that cost needs to be built into hourly rates that we use in our estimates. So the next one down, holiday pay. So that one there says at least 4%. So that's what you would start out as if you were a new hire. So at least 4% of the employee's total wages during the year of employment, entitling the employee to vacation pay. So it's a percentage of your yearly wages is put towards holiday pay. So once you've been with a company for more than 5 years, then that 4% jumps up to 6%. Okay, so keep going with employer labor burdens. So employment insurance. So this is the EI premiums. As an employer, you must contribute 1.4 times the amount of EI premiums that you deduct for your employees' remuneration. So what does that mean? So an employee gets deducted some amount of money off of their paycheck on each paycheck, and it's for EI premiums. So those dollars go to the government. So that comes off of your paycheck. So the employer has to not only match that amount, they have to provide extra. They have to provide 40% more. So, for example, how that would work, if $100 is taken off your check for EI premiums and sent to the government, your employer would have to contribute an amount 1.4 times that amount. So 1.4 times 100 is $140. So off of your paycheck would go the $100. The employer would send $140 to the government for your hours, based on how much you made for that 2-week period. So, of course, all employees have this amount deducted from their paychecks, this EI premium, and the employer contributes this 1.4 times amount for all employees. So it says there in 2016, $1,337.06 was the maximum that could be deducted off of your paycheck as an employee. So over the year, over the months, I guess I should say, a little bit of EI is deducted off each of your checks, up to a maximum amount of $1,337. So the employer is putting 1.4 times that amount back to the government. So what does that look like? So $1,337.06 is your contribution, and the employer pays $1,871.88. So those two numbers would be combined and sent to the government. So the important point here is that first bullet where it says, as an employer, you must contribute 1.4 times the amount of EI premium that you deduct. So there's a calculation there. So the next one down is CPP, or Canada Pension Plan. So as an employer, you must contribute an amount equal to the CPP contributions that you deduct from your employee. So again, there's a maximum amount that is deducted. So for 2016, that amount was $2,544. So again, that amount is being deducted paycheck by paycheck from the employee. The employer is matching it. So equal amount here is the important couple words. Okay. So what these two numbers here are, the 50,800 and the 54,900. If you make, let's look at this first one here. If you make more than $50,800 over the year as an employee, the maximum amount that'll be deducted for EI premiums is this dollar amount here. If you make $100,000 in the year, the employer still only deducts this amount of EI from your paychecks. Similarly with CPP, it's a slightly different total amount. It's $54,900. If you make over this amount, again, your employer will only deduct this total amount off of your paychecks. If you use the same example, if you make $100,000 in earnings for the year as an employee, you're still only deducted this dollar amount for CPP. So there are maximums that are deducted for these two items. So employer labor burdens continued. So Worksafebc insurance premiums. Worksafebc collects insurance premiums from employers to cover the cost of workplace insurance. As an employer, you are required to pay premiums just as you would for any other insurance. So what is that premium? So there's a formula that's used on how to calculate it. So there's some base rate that is established by Worksafebc depending on what industry you work in. So construction has many different industries applicable to it. So a couple of them are listed down here. So traffic control, there's a general contracting, there's things like roofing or pile driving, paving, all sorts of different industries like that. They all have different base rates. So to calculate the premium, you take the base rate, you multiply it by your experience rating. So the experience rating applies to you, applies to your company specifically. So if there's two contractors, say they're both, let's say they're both traffic, well, let's say they're both general contractors, okay? So they would both start out with a base rate of $2.75. We'll get into the rest of this here shortly. So both of their base rates would be $2.75. If general contractor A is much more careful, they're very safe, they get no accidents, versus general contractor B always has accidents, they're always submitting claims to WCB for injured workers, etc. The experience rating for the general contractor A that does not have accidents will actually, it'll lower this base rate by a certain amount. So the other general contractor, B, who's having all these accidents, the experience rating can actually increase the base rate. So it can force you, it's a penalty is what it is. It can force you as a contractor to pay extra Worksafebc premiums based on your safety rating. So that's the experience rating. Again, it reflects individual companies and their safety rating. So you multiply those together, you then multiply again by assessable earnings. So that's how many hundreds of dollars of payroll you have. So you would simply add up your payroll for the month. That's your assessable earnings, right? And then you would divide it by this 100. So multiplying all that out gives you a premium of what you would pay for Worksafebc insurance premiums. So again, here, this experience rating part is important. It can reduce the base rate or it could increase the base rate. So there's the note there, experience rating based on safety performance of the company. So there's an assessable earnings note here. Assessable earnings are all up labor cost before deductions. And then a couple examples of base rates for different industries. So we get to this page here, and we see, so our same labor classifications here on the left. We have our previously seen base rates for those labor classifications. So then you would simply build a spreadsheet to calculate this. So your stat holidays, you'd come up with your premiums. So how do you do that? So for this first one here, the foreman, excuse me, where does this $1.32, this $1.32 come from? So you would go 8 hours in a regular workday. You would go multiply by $33 an hour. That's the base rate for this labor class. Multiply by 10 stat holidays in the year, right? Those, we said in 2016 there were 10 stats. That's what this means here, 10 days on 250. So, and then you would divide by 250. So that would give you $10.56 per 8-hour shift. So if you divide it by 8, then you would get this $1.32. So that $1.32 would be added on to the employee's base rate. So vacation pay, 4%. So it's simply $33 times 0.04. So $33 times 0.04 is $1.32 per hour. So that's the cost to the employer for your vacation pay. So EI, so again, as I mentioned, it maxes out at this dollar amount. So how do you come up with this hourly add-on? So you take the maximum, so $1,337, excuse me, 6 cents. So you're going to divide that by an 8-hour shift, 5 days a week, and 50 work weeks in the year. So that's 2,000. So 1,337 divided by 2,000. That gives you 67 cents per hour for EI premiums. So similar calculation for CPP. Again, the maximum is $2,544.30. And you would divide that by your 2,000 work hours in a year. So again, 2,000 work hours, how do I come up with that? That's 8 hours a day times 5 days a week times 50 weeks in a year. That's our, for this course, that's our standard work week, standard work year, 2,000. So $2,544.30 divided by 2,000 gives you this $1.27. The Worksafebc premium is, so how do we come up with that? So there's a star here. So note Worksafebc premiums are company specific. Okay, so the calculation here is we add up these first 3 columns. So we'll just keep looking at the foreman. So 33 plus $1.32 plus $1.32. So we multiply by the base rate for our industry. So in this example that's shown on the PowerPoint presentation, the base rate that was used was $2.75 per $100 earnings. So we've added up these 3 columns, so we have a number, so that's 3564. We then multiply by 275, so $2.75, and divide by 100. So that gives you a WCB premium of 98 cents per hour. So other burdens, we're saying in this spreadsheet here that other burdens total 3%. So 3% of what? It's 3% of the base. So $33 times 0.03 is 99 cents. So again, if you completed this in a spreadsheet, so Excel or something similar, once you have all these numbers calculated, in this last total column, you could simply add up this entire row to give you these totals down at the end. So these are the hourly rates that you would use in your estimate. So if you had a foreman in your estimate, you wouldn't use $33 an hour. You'd be using $39.55 per hour. Similar for a grade person or a pipe layer, etc. So go one more slide. So those other employer burdens, so that's what this column is here, this 3%. So we kind of expand on that just a little bit. So maybe there's things like pensions or your dental benefits. Maybe there's union dues in that. Maybe you get some allowance for education and training. Maybe you're allowed to take a course for 8 hours once a year to, brush up on your safety or something. Maybe it's a cost for purchasing your own personal protective equipment or PPE. So it is 5 to 8. So that's the end of labor. So next comes equipment costs. So before we get into equipment, let us take a through. So PowerPoint. So that was labor. So I should mention about labor that typically, I would say 99 times out of 100, that your employer or your manager or your boss will give you, the estimator, the labor hourly rates that they want you to use in your estimates. So typically you're not required to come up with your own labor rates. Those are provided to you. So the purpose of those previous slides was to make you aware that there's other costs in addition to a laborer's base rate that the employer pays. I have made some notes on the scratch board that I'll show you after the PowerPoint presentation is done on calculating overtime. So I'll turn that on once the PowerPoint is finished. But let's carry on with PowerPoint. So equipment costs, so includes things like the rent of equipment plus the operating cost. So let's look at rent first. So rent could be things like internal company rent. So it's like a amortized purchase cost or a lease cost. So it includes things like insurance or certification. So not all equipment needs to be certified. So things like, specifically like cranes, need to be certified once a year. So there's a cost to that. So that's internal company rent. There's other rates, like rental company rates. So those are based on market rates. They include things like anticipated wear and tear. Equipment rent, so it establishes a rental basis. So it could be, maybe it's 8 hours a day, maybe you're told it's 50 hours a week, maybe it's 20 hours a month. So those are some examples. That's what the rental company would tell you when they give you a quote for, the rental excavator that you want for 1 month. They'll say it's based on, so many hours a month If you go over, then there's some premium that you would pay. So next page. So equipment rents can vary dramatically depending on your geographical location. So remote locations where access is limited or equipment is not available, or it's limited availability, the rental rates go up. So it says specifically for civil areas along winters. So if there aren't many, excavators around to be rented, then the hourly rate for those limited machines that are available is going to be higher than, say, an area like the Lower Mainland here, where there's lots of rental houses. So the hourly rate would be less. So the thing to keep in mind there is rental rates can also depend on your location in the province. Typically, monthly rental rates are based on approximately 2% to 5% of the purchase price, depending on market and the anticipated lifespan of the particular piece of equipment. Weekly rates are approximately 1/3 of monthly rates. Daily rates are approximately 1/3 of weekly rates. So, for example, if you were going to rent a machine for 2 months, you would want to pay the monthly rental rate on that machine. 2 months times the monthly rental rate. You would not want to pay 8 weeks times the weekly rate. It would cost you more doing it that way. So those were the rental costs. So now we're going to get into operating costs of the equipment. So there's things like fogs or fuel, oil, grease, servicing. So heavy equipment, well, all kinds of equipment, not just heavy equipment, typically consume fuel. Varies considerably on usage. So it's based on the size of the engine, so the horsepower of the engine, and how much load it is under. So typically fuel runs, well, I mean, nowadays it's because of COVID, it's gone down drastically. But typically diesel is in the 120 to 130, so $1.30 per liter. Says their rates fluctuate considerably. And of course they do. So that's fuel. Oils, so different oils, so hydraulic oil, engine oil, depending again on the machine. Oils are a cost. Grease and lubricants, so the operator should be greasing his or her machine on a regular basis, depending on what the company's policy is. So the cost of that grease adds up. So third-party servicing, so not necessarily third-party, but servicing of machines. So the mechanic, whether it's a third party or it's the company's employee mechanic, doing services on large pieces of equipment. So for an example, an excavator or a dozer, those services are done at certain hour intervals. So in the slide there's 250 hours, 500 hours, 1,000 hour services. So each of those cost a fairly significant amount of money. So they range from $1,000 up to $2,000, $3,000, $4,000, $5,000, depending on the equipment size, what service you're doing. So a 250 hour service is typically cheaper than a 1,000-hour service. So that's probably your biggest operating cost, possibly next to fuel, depending on the machine size. So materials associated with the servicing are things like filters, so air, oil, fuel filters, belts, hydraulic lines, etc. So continuing on with operating costs, so you get into things like wear and tear. So for tired or tracked machines, so the cost of those tires, the cost of the tracks. To replace those is a fair amount of money if you need to buy a new tire or replace tracks. Things like attachments. So buckets need new teeth. Dozers need new cutting edges, or sometimes blades, but more often cutting edges. So if we look at this photo here of this excavator bucket. So the first bullet here, bucket teeth. Well, of course, these are the teeth out front. So when digging in quite hard ground, you have a digging bucket like this with teeth on it. So these teeth are the surface that's going to wear on typically on an excavator bucket. They are the first point of contact into the ground. So another part of the bucket that can wear are the sides of the bucket. So as you dig into a trench, or you're creating a trench by digging, the sides of the bucket are rubbing along the trench sides. So actually the side of the bucket can wear down. So typically what companies like to do is weld on these plates onto the sides of the bucket so that those plates are going to wear instead of the bucket itself. The teeth and those wear plates are easily replaceable. If you need to purchase a new digging bucket, it could be easily $5,000 or more, depending on the size of the bucket. So some welding time and some relatively inexpensive steel plate can save you the significant cost of replacing buckets. So there's a similar concept with dozer blades. So the blade itself has on the bottom of it plates that are bolted on. So those are the cutting edges on a dozer blade. So that's the first point of contact for the blade to the ground. So those plates are going to wear, so those are replaceable. So operating components, so things like motors need to be rebuilt every so many thousand hours, significant number of hours, but that needs to be thought of. Different pumps, water, slurry, etc. So you may have a program where you repaint your equipment every 7 years or something. So there's a cost to that painting. So the amount of wear, so wear and tear, depends on things like the location. So this is geographical location again. So us in the lower mainland where we don't see much snow, we don't get a whole lot of salt on the roads, versus a place like maybe Toronto where there's lots of snow, where there's significant salt used. There's a lot of corrosion on metal from the winter. So the next one here, material that you're traveling on. So are you working on sand? Are you in a gravel pit? Are you on clay? So different materials will wear your equipment down at different rates. So how abrasive? Okay. So for us right now, the equipment costs do not include the operator. So labor is not included in equipment costs. So the next bullet down, so may not include extraordinary wear items. So what does that mean? This one down here, so a dozer undercarriage. So that's everything on a bulldozer underneath the cab. So similar on an excavator, everything under the cab. So it's the tracks, it's the turntable for an excavator. So the undercarriage. So there's a note here says to replace an undercarriage on some size of dozer is, could be $200,000. So that's a significant amount of money. You got to think about things like transport trucks. Are they traveling on paved roads or forestry roads? Obviously, one is a whole lot smoother and easier on trucks than the other. So for external rentals, so if you go out to a equipment rental house, does their rental rate include things like servicing? Will they come and service your generator, every 200 hours when it needs it? Will they service the air compressor? Things like that. Will the excavator rental house come and service the excavator? So again, those servicing costs can be large. So the next one down there, operating hours. So are you running that excavator 8 hours a day? Or do you have a generator that you're renting that's running 24 hours a day, 7 days a week? So the hours that it's operating have to be thought of as well. So this last one here, consider cost of downtime during servicing or major overhauls. So if back to the 200-hour service, or the 250 or the 500 or the 1,000-hour service, those can typically take the better part of a day to do. So if you have your excavator that you're using every day, and all of a sudden it's taken out of service for a day because it needs to have its 500-hour service done, what are you going to do? Do you have to rent another excavator for the day, or can you do without it for the day? So there's alternative sources to get equipment costs or equipment rates. So there's a book that the BC Road Builders puts out. So that's these guys here. It's called the Blue Book, and everybody knows it by that. It's the cover of the book is blue. In it so it's published more or less every year. They skip the odd year every now and again. Oops. But the Road Builders puts this publication out in partnership with the Ministry of Transportation. So it's a rental rate guide. So the thing to note about that is these are charge out rates. So they include overhead and profit. So you wouldn't use the rates in the Blue Book in your estimate because they're already quite a bit higher. The reason this is mentioned is it gives you an idea on hourly rates for a whole broad range of different equipment, from trucks, excavators, dozers, scrapers, tractors, backhoes, concrete equipment, cranes, a whole range of different types of equipment, pumps, pickup trucks, all sorts of different things. So that was equipment. So now on to materials. So permanent materials versus construction materials. So what's the difference? Permanent materials, part of the constructed works. So that includes things like the pipe that is required for the utilities, the road structure, so the road base, the road subbase, the asphalt, different things like that. Those are permanent materials that stay on the project once the project is finished. So it says there, they are shown on the drawings. It says, though some may be intuitive, things like for pipe, it's the bolt and gasket sets to attach different types of pipe and fittings together. Usually the bolts and the gaskets aren't shown on the drawings. Sometimes the fittings, so a bend, may or may not be shown. The bend in the line will be, there just won't be a note saying, 90-degree bend. Next bullet down, so there's specifications provided either on the drawings or in the specification book. That's what separate document is. So you're told exactly what to provide that is required on the job. So the difference between those permanent materials and the next section down, construction materials, are the construction materials are required to build the project. So things like concrete formwork or access roads. So those types of materials are needed to build the job, but they don't stay on the project after it's completed. So the concrete contractors' formwork, they would take with them to the next job. They don't leave their formwork on that job site. So as it says, they're typically removed from site at the end of the job. Ideally, those materials are reusable to reduce project-specific costs. So the concrete contractor would use the same forms from job to job, ideally. At some point, they would need to replace them because they would wear out or get damaged. So materials continued. So materials are provided by suppliers or vendors. A contractor may have a preferred list of suppliers or vendors that provide them with more competitive rates due to the contractor's loyalty to the supplier. So ideally, you would want to compare, so you as the estimator would want to compare at least 3 separate quotes from 3 different suppliers to ensure that you are getting the best quote. So if you only get 1 quote, 1 or 2, maybe you're not getting the best rates for the materials. So ideally, you would have at least 3 quotes to analyze. Supplier quotes have a validity period, so they're open or they're typically for 30 days. So if you, now it says here, you may need to specify a longer if the tender requires it. Most suppliers will say, valid for 15 days or 30 days. If you go over that, if you give them a purchase order, 50 days from the time of quote, they'll usually honor it. Specific things like steel that needs to be brought in from out of the country, maybe from the United States or from China or something, those raw material costs fluctuate so much that the local supplier can't hold their quote for more than typically about 15 days, so 1-5. So it is important to look at what the quote is valid for, how many days. So next bullet down, ensure the material that's priced matches the spec or specification, or it's an approved alternative. So cheaper alternatives may not be accepted. So if you get 3 different quotes for your water main valves for your water line, you notice 2 of them are similarly priced at $1,000 each, but the 3rd supplier quotes a different type of valve at $500 each. Well, you may be tempted to go with the $500 valves because they're cheaper, but it's possible they will not meet the spec. So the owner may not allow you to purchase those cheaper valves and install them on their project. So the issue there is you may have 25 of those valves in your estimate. So if you only have $500 per valve, so quick calculation, $500 per valve times 25 valves, so you have $12,500 in your estimate to purchase valves. Well, if the owner says those valves aren't acceptable, they want the $1,000 valves, and they have every right to do that if it's written in the spec that way, then you have to supply $25,000 worth of valves, but you're only going to get paid $12,500 for them. So you're going to lose $12,500 on the purchase of your valves. So reading the specs is very, very important. And corroborating the specs with the materials that your subs are quoting on is also important. Excuse me. So the last bullet, ensure the material is available within the schedule. So sometimes if you have maybe really big diameter pipe, it might be special order. Maybe the factory has to produce it specifically for your job. So maybe it takes 4 months to get that pipe. Well, if that delivery schedule doesn't work with your overall project schedule, then there's a problem. So typically suppliers will say on their quotes what the availability is of the materials. Maybe they'll say in stock, so it's readily available, it's in their yard right now. Or maybe they'll say it's a number of weeks out from time of order. So that's also something to be aware of when analyzing supplier quotes. So materials continued. So ideally, they match, so the quoted cost for materials, ideally, they match the tender form. So what does that mean? So have your supplier provide unit prices based on what the tender form is. So if you're asking for pipe quotes and your tender is in lineal meters of pipe to install, you want your pipe supplier to quote the pipe based on a lineal meter, so many dollars per lineal meter. Similarly for gravels, if your tender is in so many tons of gravel, you want your gravel supplier to provide you with gravel pricing based on dollars per ton. They typically do that, so that specific example is not an issue. Maybe a better one is paving. Sometimes paving can show up in tenders as so many tons, or it could be square meters based on a depth. So whatever your tender quantities are, so the units for them, you want your sub or your supplier to price those same units. So if your tender is 1,000 square meters of asphalt at some thickness, you want your paving sub to price the paving at so many dollars per square meter, so that you can simply plug those rates into your estimate. So the second bullet, specify to the supplier or confirm from them what the delivery is. So in other words, do you, the contractor, need to go to their warehouse or their yard and pick up the materials? Will the supplier put their materials on a truck that they set up and pay for and send the truck to you? do you as the contractor need to unload that truck, or will the supplier send out a truck that has like a high ab on it that can unload itself? It's like a crane truck. So what the delivery is also important. So is it being delivered to your site, or do you need to go get it? So the next one down, materials include 7% PST. Now, most suppliers do not include PST in their quoted rates. You have to add that on after the fact. So PST, I guess that's all I'll say about PST. It applies to all materials. PST also applies to equipment rentals. We're not going to get into that too much in this class, but just so you're aware, if you go and rent a pump from United Rentals, they're going to charge you PST on that pump rental. So the last one there, do not include the GST. So that's general sales tax. PST, of course, is provincial sales tax. So do not include the GST in your estimate. There is always a line item on a tender form, a separate line item for GST. So that's always shown separately, usually at the bottom of the tender form. So you never include GST inside your estimate anywhere. It's, again, as I say, it's shown separately by itself. So next slide here, quantity takeoff, or QTO, quantity takeoff. What is a quantity takeoff? Quantity takeoff is a process used to determine an itemized list of construction materials from project drawings. So it's a list of quantities. Quantity takeoff process. So things to keep in mind. So use the latest set of drawings and specifications. So we went over last week how drawings have a revision number on them. So make sure you have the latest revision. Details can change from revision to revision. Identify all elements associated with the scope of work being estimated. So identify elements according to the tender form. So correlate your tender form with what's shown on your drawings. We'll get into that a little bit later. Also, consider grouping elements into a work breakdown structure. So we'll get into that on the next slide. So things like road building, utilities, erosion and sediment control, etc. So calculate the quantity of each element. Activities and materials required for each element. So you're also going to want to have a waste factor for some of your materials. Things like, lumber and pipe, they're going to have a waste factor. Aggregates will have a waste factor. So sometimes you'll bring gravel to site, you'll get all the trucks to dump it into a stockpile, you'll come back later using maybe your excavator, and you've got a tandem dump truck on site. You'll reload that gravel into the tandem and drive it around your job site to where the gravel needs to go. Well, there's always waste on the ground. You're never able to pick up every last stone. So there's a percentage waste factor. So this slide here is so quantity takeoff. So it's a sample concept. Shows things like, so 1.0, this is your tender item. This is what shows up in the tender package. So the first item to price is site preparation. The tender units are square meter. You're given a quantity to price, 500 square meters. So the next bid item might be this one down here, installing road base. So what's all the rest of this stuff? This is where your work breakdown structure comes into play. So in the site preparation bid item, maybe you need to include things like clearing the trees, hauling those trees away, stripping the topsoil at, let's say it's 100 mm depth, hauling that soil away. So all of these costs are included for this example in this site preparation. So there's a question, Rodney, do we need to add possible mistakes of the employee? I would recommend you don't add costs like that into your estimates. Assume that mistakes are not made. Yeah, I mean, that's the simplest answer. When you start adding in all possibilities, your estimate cost goes sky high. So it's best to keep things like possible mistake costs out of your estimate. So got tender item 1.0. So the next tender item might be 2.0. So installing imported granular base with some quantity here. So your work breakdown structure might be for this one. So you're purchasing aggregates. Maybe you need to install some culverts for whatever reason. That's would typically be another bid item, but maybe for this example, it's included in here. So you purchased aggregates, you need to spread your aggregates. Maybe you need to install that culvert. You need to compact your aggregates. Typically water and compaction go together. So for any given tender item, you may have multiple WBS items, so work breakdown structure included in it. So Rodney had a situation, employee built a brick wall in the wrong location. Okay, yeah, I mean that's you can't build that into an estimate. You can't build a wall being constructed in the wrong location into an estimate. Your $50,000 estimate will blow up to $500,000 if you do that with all different types of materials and tasks. You just need to hope that your supervision is good enough that those mistakes don't happen. Okay, so identify the resources required. So labor, equipment, and materials. Okay, so I mentioned when we came back from the break that I made some notes here on overtime calculation. Make sure that's in the screen. So yeah, so hopefully, can everyone read what I've written here for overtime? Not clear? Okay, let me see. Spotlight video. Okay, is it written too small? I can rewrite it so it's bigger. It's blurry, okay. But move the camera away from it. Does that help? No? Okay. Yeah, unfortunately, this is the only webcam I could find. Every place is sold out. Maybe I will I'll post this to the news feed so that you can download it, so that you have it. You'll need something like this for this week's assignment. It'll help you with the a couple of the questions, or one of the questions, I should say. Okay, yeah, I'm not sure I can change the quality of the video. Video settings. How's that? There's a HD button that I just clicked on. No, still not very good. Okay, well, I'll post those notes to the news feed so that you have them. Okay. So the last thing, what time is it? 8:44. So the last thing we're going to do is do a quantity takeoff exercise in class here. So if I bring up, I'm going to bring up my drawings again. Find those. There they are. Okay, so back to the drawings. We're going to look at trying to calculate a few different quantities on the drawings. We'll do this together. We'll kind of skip through it a little bit quickly so that I can issue the exercise for this week. I'll need to post it onto the Learning Hub, and I'll also post the overtime notes there as well. Okay, so we're going to look at calculating parking lot lines. So quite often you will need to know the lineal meters of line paint that you need to apply. So again, this is just an exercise in doing a takeoff. So just one example. So here's our parking lot. Again, it's the dark gray area. So of course the lines are these stall lines here, right? So those go all the way around. So down this far east end, if I zoom in a little closer, there's also things like this drop-off zone. There's a paint line there. We're given a length of it. Then there's some other things like this drop-off zone here. There's a line there. And there's possibly another line here. It looks like there is anyway. So how would you take off something like this? So you're looking for lineal meters of line paint. So there's probably a few different ways to do it, but my example that I've got written down here is, so for most of these lines, we're told that the stall length is 5.6 meters. So the length of this line is 5.6. So we could simply count the number of those lines all the way through. So all these, those couple here, there's some down there. And that's the extent of the 5.6 meter lines. So I believe there's 27 of those. So you would go 27 times 5.6, gives you the overall length of all those lines. So the next ones, so these lines down here are slightly shorter. They're 4.9 meters. So again, you could count those up. I believe there's 10 of them. So there's 8 there, and there must be 2 others. Maybe these 2 are shorter. Yeah, it looks like they are. These are shorter than those ones. If you look at where the curve is here. So there's 2 here, and then there's 8 more over here. So you have 10 times 4.9 meters. So then you've got a drop-off section, we said here, this one. So it's actually dimension for us, so 17.45. You could add that to your total. And then this last section here. So looking at the stations, so from 200 to 220, it looks like it's about 20 meters long, and then it returns here, so there's some additional length there. So this one is approximately 23 meters. So if you summed all of those up, you would get a total length of line paint of approximately 240 meters. So other things like the arrows, you would count those, you wouldn't measure the length of those. You would typically measure each of them. You would be charged by the painting contractor per arrow type thing. So there's 1, 2, 3, 4, 5, looks like there's 7, looks like there's 9 of them. So you would have 9 arrows. $20 meters came from, if I zoom in a little closer here, if you look at the station here of the control line, so right here is 0 plus 200. Okay, and then down here is 0 plus 220. So the distance between those 2 stations is 20 meters. So this line is approximately 20. It starts further back and it ends just short. So I'm saying it was approximately 20 meters, and then it turned the corner here. So again, you would use your scale on this with your scale factor to come up with these lengths. Probably just these 2 you would need to scale. All the others are given their dimension for you, right? These ones. Okay, so that is the line paint. So another possible calculation you might need to do is, and this is hard for me to do on a PDF, but it's the area of the pavement. So again, you would do this with your scale. So the question, can we still use a scale if we don't have drawings, only PDFs? No, unless you have some type of on-screen takeoff software, you won't be able to scale off of PDFs. So coming up with an area of this asphalt, just so you know, you will not need to scale these drawings for any tests, or I don't believe any assignments either. I'm just flipping through today's assignment. Yeah, you don't need to scale drawings for today's assignment. Okay, so coming up with area of the asphalt. Question for Alex. No, you do not have to print 2-foot by 3-foot drawings. The request before this class started was that you printed 11 by 17 drawings, so 11 inches by 17 inches. That was posted back in December. So ideally, everybody had hard copy 11 by 17 drawings that they could scale off of. I believe this week, actually maybe next week, is the last time we use these drawings. Just going through next week's assignment. Yes, you will want hard copy. Yes, 11 by 17s is what you need. So if we were going to take off the paving area for this parking lot, ideally you can do one of two things. If you have software, like for example PlanSwift, you could take off this area quite quickly. I'm not going to get into PlanSwift how it works, but it allows you to take off simple areas and lengths and volumes using PDF drawings. Otherwise, you would need to print this out on paper and use your scale to come up with areas. So you would break it down into manageable areas. So, you know, rectangles, squares, that type of thing, triangles. So you would, by all means, you would draw all over your drawings. Putting pencil lines or pencil crayon lines on your drawings is totally acceptable. They do not need to be handed in to anybody. They're yours to keep, not only in this class, but also in the real world. Your tender drawings, you don't have to give to anybody. No, there's no CAD file for this. So again, you would go through here using easy shapes to calculate areas, rectangles, squares, triangles, and come up with an overall area. This parking lot is approximately 1,600 square meters. So our last takeoff, we'll go back to the water meter chamber that we looked at previously. So this is drawing 9549. So we're looking at valves here. So you want to be careful when you're looking at a detailed drawing like this. So this is the plan view as it's stated here. Below it is the section. So of course it shows the same information, plan view versus section view. So this valve is the same as this valve. So you don't want to count all the valves on the plan and then recount them all again in the section. You're going to have double the amount of valves in your estimate. So what kind of valves do we have here? So there's a call out here, it's called number 1, and it's pointing to here. So we would look at the notes to see what a number 1 is. So it tells us it's a 200 millimeter isolation valve. It's a gate valve. So there's 1, 2, 3, 4 of those. Four of those, and then so those are all 200 millimeter in size. There's this valve up here, which is a number 2 call out. So it's a 150 millimeter isolation valve, a gate valve. That was for the bypass. So it's just a smaller size, 150 millimeter diameter versus 200 millimeter. So we would have one of those. So then, yeah, if we look at the notes here, the actual water meter is call out number 3. So this is the actual water meter right here. So those are the valves that would be included with this meter chamber. So obviously there's other pieces of equipment here that you would also take off. right? Using the legend here on the side and counting all the different pieces that are shown on the drawing. So again, just to show you that this water meter chamber, the detail for this shows all the valves that are needed. Whereas if we went back to the utility drawing in our drawing set, so the servicing plan, and we zoomed in on where that valve chamber was, right here, it doesn't show any of those valves on the main plan view. So we would have missed 5 valves in our estimate if we didn't go to that detail drawing, as well as all the other components that are listed there. Okay, so any questions on those quick takeoffs that we went through and looked at? No? Okay. So what I'm going to do right now, I'll stop my screen share. I'm going to upload, close this. So I'm going to go onto the Learning Hub. And I will upload today's assignment in Word format. I will also upload the notes that I have on the kind of the overtime rules, how overtime works. So just thinking how I want to do this. Okay, so I think for right now, I'm going to stop the recording so it doesn't go on too much longer.